Okay, ladies and gentlemen, we're going to be doing lesson 6-4 over elimination using multiplication. Your learning objective today, so go ahead and please follow along in your notes. Write down, we will solve systems of equations using elimination with multiplication. Of course, systems of equations means how many equations? That's right, 2 or more, okay? And we will be solving those today. Very, very similar to what we did yesterday, okay? Of course, with videos, at any point, if you need to stop or go back and listen, that's fine. That's the benefit of a video, okay? So let's proceed. We're going to go to our steps, okay? This is a very formal list of our steps, 2 of which we have already been doing, okay? The new step that we're going to be adding today is number 1, where we multiply at least one equation by a constant to get 2 equations that contain opposite terms, okay? So as you see right here, if we start off with -2, the opposite of -2 is, the opposite of +2 is -2, right? And if we're looking at -5, what is the opposite of -5? Good, +5, right? So that's what we're trying to do. We're trying to multiply by a constant to get 2 equations that contain opposite terms. And this will make more sense as we get into the first equation, okay? And by the way, do you remember what a constant is? A constant is a number without a variable, okay? It's going to have the same value. A 2 will always have the value of 2. It is constant. So step 2, we're going to add those equations. And of course, anything that's highlighted is all that you need to write down in your notes. We're eliminating one variable, just like we did yesterday, and then we solve the equation. Step 3, we substitute the value from step 2 into the equations, and then we solve for the other variable. And finally, we always write our solution as an ordered pair. Okay? So today we're going to be, in this video, we're going to be following along the notes pretty strictly. I'll have another video, or we'll do it in class with all of the examples that you can work out. Okay? So let's start off with example number 1. Here we're going to use elimination to solve the system of equations. Okay? Do you see anything that looks different from yesterday? If you said that it's kind of missing 2 terms that kind of cancel out, you're right. Which terms do you think would be the easiest to like multiply and create an opposite term? Okay. Well, if you said this plus y and the plus 2y, I agree with you. Okay. So let's think about this. Okay. If I am looking at 2y, what's the opposite of positive 2y? Negative 2y. Good. Now, that's what I want this to be, right? I want that to become negative 2y. So with multiplication, because we're going to multiply, what do I have to multiply times y in order to get negative 2y? Good. Negative 2. Negative 2 times y is negative 2y. But here's the thing. If I multiply this by negative 2, I got to multiply everything by negative 2. So I'm going to take this right here, and I'm going to say negative 2 times 2x plus y is equal to negative 2 times 23. The exact same equation, just with negative 2 multiplying everything there and negative 2 multiplying everything there. We're going to apply a little distribution. We're going to say negative 2 times 2x, negative 2 times y. Okay, so we end up with negative 4x and negative 2y. On the other side, we end up with negative 2 times 23. This is negative 46. Yay. We have created an equation that contains a term that is opposite of this term. Fabulous. Now we can move on to step 3. So I'm going to drag this equation right underneath. And we're going to do this. We have 3x plus 2y equals 37. And we're going to add this. Negative 4x plus 3x, negative 1x. How come I didn't put the 1? Because it's a ninja 1, right? If you only see 1x, then it's 1x. All right, 2 minus 2. 0, right? Goes away. We don't even have to write it down. Okay, we've got negative 46 plus 37. We have different signs, right? So we want the difference, which is 9. And we keep the sign of the larger number, negative 9. Now, the only problem is I need positive x. So you can multiply by negative 1. You can divide by negative 1. The results are the same. The sign changes. It goes from being negative x to positive x and negative 9 to positive 9. We just switched those signs. So ladies and gentlemen, we have figured out what x is now. So we can take either one of our equations from our original 2. I'm going to go with the top one because it looks a little easier. And I'm just going to substitute. Which variable am I going to replace with parentheses? If you said x, good for you, because that's what we know. We know what x is. So we're going to take this, and instead of x, I'm going to put in parentheses, plus y equals 23. And inside of x, I'm going to put 9, because we're substituting, right? So then we end up 2 times 9, 18, plus y equals 23. Okay, how do I get y all by itself? Subtract 18. Subtract 18. Very good. And finally, we end up with y is equal to 5. Is this how we want the answer? Can we just circle it and say, yay, we're done? No. Make sure that you write your answers as an ordered pair. And there you are. Questions? Make sure that you write down any questions, or if you're in my class while you're watching the video, raise your hand, okay? But if you're at home watching the video, make sure you write down all questions. I'll be sure to answer them in class. Okay, let's flip to the back side of your notes. I'll try to remember to keep it nice and loud for you. We're going to use elimination to now solve this system of equations, okay? Do you see, because remember the first step was that we had to multiply something in hopes of getting an opposite number. Do you see any term that lends itself well to that? If we look at 4x and 3x, does 3 go into 4? No. What about this one? We got 3y and negative 5y. Does 3 go into 5? No. So unfortunately, this is going to involve multiplying both equations. A little bit more work, but not impossible, okay? So we have to think. Let's stick with the positives. What does 4 and 3 both go into nice and evenly? Okay, what are they both factors of? What is the smallest number that they're both factors of? If you said 12, absolutely, okay? So our goal is to be, what can we do to get those numbers to look like 12x? So let's start off with the top one. Here's my 4x, and there's 12x. Let's scoot that over a little bit. Sometimes I wish I could do this on paper. Okay? What am I going to have to multiply times 4x in order to get 12x? If you said 3, good. Now let's look at the bottom one. Same deal, okay? I'm going to have to multiply something times what is already there in order to get 12x, because we want to get the same thing. And actually, I want to get the opposite. So let me make this negative 12x, right? So I'm starting out with 3x. And basically, the x stays the same. So what do I have to multiply times 3 to get negative 12? Well, you answered negative 4. Good. Okay? So we're going to go ahead and apply the 3 times the first equation and the negative 4 times the second. So show you what it looks like. 3 times 4x plus 3y equals 3 times 8. Okay, I'm going to do the same thing here. I've got the bottom one, 3x minus 5y equals negative 23. And what I'm going to do is I'm going to multiply the bottom one by, that's right, the negative 4 that we decided. So negative 4 times this and negative 4 times that. Okay, let's go ahead and apply a little distribution. Negative 4 times 3x, negative 12x. Negative 4 times negative 5y, positive 20y. This is equal to a negative times a negative, positive, and 4 times 23, 92. Okay, let's do the top one. 3 times 4, 12x. 3 times 3y, 9y. 3 times 8, 20. Okay, 3 times 8 is 24. So what we want to do is we want to take these two equations, right? I'm going to rewrite this. Okay, I'm going to start off with 12x plus 9y equals 24. That's the top one, right? And then I'm going to bring down the bottom one. Negative 12x plus 20y equals 92, right? Now when I do this, the 12's cancel out. I'm left with 29y equals 116. Okay? Finally, we're going to divide by 29, divide by 29, and let me get my calculator, so wait one moment. All right, and so in my calculator, I said y is equal to 4. Let's see if I can find a clean place to write this. Y is equal to 4. Good. I'm halfway there, right? So the next one. I'm going to pick one equation to put it in. Let's see, which one do I think looks easier? I'm going to choose the one that's all positive. So that's 4x plus 3y equals 8. This is one of my original equations, right? Okay, I'm trying to remember to talk loud. And I'm going to plug in. So what variable am I going to replace? Y. Because I know what y is. Y is 4. So I'm going to plug that in, 4. We end up with 4x plus 12 equals 8. Subtract 12, subtract 12. 4x is equal to negative 4. What do I do now? Divide by 4. Divide by 4. And x is equal to negative 1. All right, ladies and gentlemen, we're ready to write our final answer. Which one goes first? Negative 1 because it's x, it's alphabetical order. And then finally, 4. All right, good job. We just got one more example to go through, and we are done with this lesson. All right, so hold on. Okay, we're back for our last example. This is example 3 in your notes, okay? We have a fishing boat that travels 10 miles downstream in 30 minutes. The return trip takes the boat 40 minutes. So we find the rate in miles per hour of the boat in still water, okay? So let's look at a couple of things. Number one, a couple of things that we need to understand. The first one being that we are going to make B be the rate of the boat in still water. That's what we're looking for, right? So that's what B is going to be. Now, the other thing, and I can kind of draw my little picture, yes? If you're going, have you ever been to Guadalupe River? And you go in the tubes, right? And there's this, well, if you haven't, there's these rapids, right? There's the current. And when you go with the current, you can actually just sit there and it'll take you floating along. That's why people go tubing, right? The waves just kind of take them along. So if you're going with the waves, right? If you're headed this way, the waves are headed this way. You can actually, if you have a little boat, if you have an engine, there's your speed plus the speed of the current, right? And you can go pretty fast, yes? But if you, for whatever reason, have to go upstream, okay, it's a lot slower because there's the speed of your little boat, right? But you're fighting the current that is coming at you, right? So that's going to be slower. That's why in downstream, we went a lot faster because it only took us 30 minutes. And to go upstream, it took us longer. It's 40 minutes. So that's 10 miles both ways, right? But that's why it took that difference in time. So let's look at what else we want to identify. Since that's important, we do have to identify what the rate of the current is. So we're going to allow C to be the rate of the current, okay? We're going to use the formula that you know in science of rate times time is equal to distance. Yes, y'all have all heard of that? Okay, rate times time is equal to distance. Okay, so these two variables, these are both rates. B and C are both rates. Do we know the time? Yeah, we know 30 minutes for one situation, 40 minutes for the other. So that sounds like two different equations for me, right? And we're going to write those. Let's see if there's anything else that we should identify. Okay, there's our formula. RT is equal to D. And since the rate is miles per hour, we do need to translate these minutes into hours, right? So 30 minutes is what part of an hour? She said 30. Good try. But 30 minutes is actually only half of an hour, right? Because how many minutes are in an hour? 60, right? Okay, so what you have here is you take 30, you divide it by 60. You can put it in your calculator, hit math, enter, enter, or you could use your brain, either way. And you could say 30 divided by 60, it actually reduces down to 1/2, right? Now let's look at this other one. What about 40 minutes? You want to redeem yourself? 40 minutes is what part of an hour? He says 2/3. Y'all agree? Yes. If we put it over 60, that ends up being 2/3 of an hour, okay? So that's how we translate. We got to make sure if we're doing this miles per hour that we really need to be working with hours, right? So let's go ahead and let's write our equations. I'm going to use a little grid, the kind that you have on your notes here. I got 5 going across. And boop, there we go. Not exactly where I want it, but okay. There we go. All right, so ladies and gentlemen, what we're going to do is we're going to go ahead, and I just use the grid to kind of help me get organized, my thoughts getting organized. We know that the formula is rate, okay? Rate times time. And if you wanted to follow along, so rate times time equals distance, okay? So this is what I would write right above. I've got 3 rows, so I'm going to move it down. Maybe not. I'll just leave it up there. Okay. And then I'm going to start filling things in. So the first one, let's do it when we're going downstream. Okay. Downstream is where everything is fun. We're going fast. Okay. So our rate for downstream, I'm just going to call it, let's see. Well, our rate, let's fill in what we do know. Okay. The distance every single time was what? 10 miles? Yeah, I agree. 10 miles, right? So every single time in this column, I'm going to put 10 and I'm going to put 10. This was miles, right? Both times. We also know the time, right? So this half an hour was 30 minutes. That's downstream, right? So I'm going to put that right here as 1/2. Okay, that was half an hour. The other one was 2/3. Okay, and we're going to multiply that times rate. Now, rate is where it gets a little bit tricky. Because remember how I said that when we're traveling in the water, that when you're going downstream, you're going fast because it's the speed of the boat and the speed of the water, right? So we have 2 different variables. We have B, the rate of the boat, and B, the rate of the current. So that's B plus C. Okay? Going together, you're going extra fast. When you go upstream, it's going against you. So here's the speed of the boat, but we're going to subtract the speed of the current. And now we've got our two equations, okay? So let's go ahead and write this out, and we're going to solve it. Why am I subtracting? Okay, so should I identify who you are on the video? Oh, okay. So my mystery student was wondering, why are we subtracting? Okay. Can anybody tell me, why do we subtract the current when we're going upstream? Yeah, we're trying to isolate what our speed is, right? It's like, have you gone to the river? Have you gone to the Guadalupe River? Okay. If you ever try to go upstream and you look at your legs in the water's actually going against you. It's really hard to go up the stream depending on how fast the water's going, right? So it's working against you. So even though your speed may be constant, that speed is going against you. It's going to slow you down. So we have to subtract to bring that number down. Does that make sense? Okay. So let's go ahead and let's finish up this so the video won't be too long. We have 1/2. I'm just going to rewrite it a little bit different. Well, no, I'm not. We got b plus c times 1/2 equals 10. And we have b minus c times 2/3 equals 10. Okay. Now I'm going to distribute. So it looks a little bit more like what we've been dealing with. 1/2 of this, 1/2 of that, 2/3 of this, 2/3 of that. And we're looking at 1/2 b plus 1/2 c equals 10. And then we have 2/3 b minus 2/3 c, and that equals 10. Okay? So now we want to identify two variables, or two terms rather, that look pretty easy to eliminate. Does anybody see one that they think would be easy to eliminate? Easier than the other? The B or the C? Hmm? I think the C, because you already have one that's positive and you have one that's negative, right? Okay. So we need to figure out, we wanted them to be opposite numbers, right? And we can't do it by just multiplying one of them. We actually are going to have to multiply both of them, okay? So what does 1/2 and 2/3? I can make them both go into, does anybody know? 6. I could see 6. I could see 6. Maybe 6 on the bottom, right? Maybe. Um, hmm. We could also, we could make both of those fractions go away. Do you remember how to make fractions go away? Multiply by that denominator, right? So if we do that, although you could work in the 6 there too, but if we multiply by the denominator, what are we going to multiply this first equation by? 2. Okay, we're going to multiply everything by 2, and if I do it on one side, I have to do it on the other, right? And then on this one, in order to get rid of that fraction, actually, I want to get rid of the whole fraction. So not only do I multiply by the denominator, but I multiply by its reciprocal, right? So that's going to be 3/2. And that'll get rid of all of those fractions so that we're looking at 1 and -1. And so I'm going to do it on this side too. Okay? So let's rewrite this. This is going to be 2 times 1/2 b and plus 2 times 1/2 c equals 2 times 10. Okay? That ends up canceling out. We've got b. This cancels out. We've got c. And 2 times 10 is 20. So there we are, right? Let's do the other one. I'm going to rewrite it. So this one's going to go down here. I've got 3/2 times 2/3 b times 3/2 times -2/3 c equals 10 times 3/2. Okay? Bringing it down. Look at y'all doing these big boy, big girl problems. All right, 2 goes into 10 how many times? 5. So we got 5 times 3, which is 15, right? Then the 3 cancels out, the 2's cancel out, and all I'm left with is negative. Positive times a negative is a negative, and we end up with -c. The 3's cancel out, the 2's cancel out, and all I'm left with is B. So we've got these two. I'm going to stack them up. We've all done the nitty gritty already. So all we have to do is stack them up. I've got B plus C equals 20, and B minus C equals 15. Stack them up. What's B plus B? 2B. C minus C goes away. 20 plus 15, 35. Divide by 2, 2. B is equal to 17.5. Okay. Now what was B again? After all that work, the rate of the boat in still water. Is that what they wanted? Find the rate in miles per hour of the boat in still water. So I'm going to write my answer. The rate, okay, we're going to pretend I can spell. Try this again. The rate of the boat in still water is 17. Okay, try that again. 17.5 miles per hour. Is that really fast? You can't even do that like in a school. Like you can go faster in a school zone. I think you can go like 20 or 35 depending on the school zone. So that's really slow actually, right? All right. So ladies and gentlemen, that's the end of our examples. I hope you enjoyed it. If you bring back the challenge question, I'll be super excited. I'm going to put out another video for the different examples and good luck guys. Good night.